So in this video, we're going to learn how to solve similar right triangles. So just looking specifically at right triangles, you can state how three right triangles are similar, and you can use proportions to solve lengths in similar right triangles. Alright, so the similar right triangle theorem is that if an altitude is drawn from the hypotenuse of a right triangle, so we have one big right triangle on the outside, and we took the altitude and drew it to the hypotenuse, your longest length. Two triangles are formed that are similar. So the big triangle, ABC, is similar to your two smaller triangles. Alright? And so, what I suggest, and now notice here I just drew out three triangles. I just took them and rotated them. So the D's and letters. For every problem that you're doing in this section, you should do this. I highly, highly recommend it. It will be way easier to solve and you'll see me do it in the notes. It is too hard to try to set up your proportions and solve when you're just looking at this. You need to, if you rotate it and make everything look the same, you'll easily be able to figure out what your proportions are versus this figure here. Alright, so again, draw out your three triangles. So here is my first example. We're going to find the value of the variable. So we have the variable x. So you have your small right triangle. Okay. Then you have your medium. And then you have your large. So you have mama, papa, and baby. Alright, so let's look at the small right triangle and let's figure out what you actually know for sure. So we have the small leg, which is always part of the big hypotenuse. We do not know that. The median leg is x right there. So we can put x right here. Now notice 3 is the hypotenuse, and the reason I know it's the hypotenuse is because it's across from the 90-degree angle, so 3 goes here. I know this is part of the 5 here, but I don't know exactly. So then we look at this triangle. The small leg is always the altitude on the median triangle. And that happens every time. And we do know the hypotenuse here is 4. And then we have the bigger triangle, where the small is 3, and we can know that by the length. This is 4, and then this is 5. So now I can set proportion. I only need one or two pairs that correspond. So taking a look. Here, if I look at this one, I have x. X goes with 3 over here. 4 is hypotenuse, and 5. I have 3 lengths and x, so I can set up my proportion just like we did previously. I can go x goes with 3, and then we can go 4, because 4 and x are part of the same triangle, over 5. Cross multiply, I get 5x equals 12. Divide by 5. Rounding to the nearest tenth, x comes out to be 2.4. And again, you can check it if you want to by setting up a proportion and the ratio of the sides. So again, really hard to see when in the picture, but when I drew it out, and the hardest part is putting everything together. But the thing you have to remember, the long leg is always the altitude, the line in the middle of the small triangle, and is the short leg in the median triangle. Every time. Alright, so find the values of variables. So first thing to do is to draw out my three triangles. We have baby, we have mama, and we have papa. Alright. So let's look at our small triangle. We have 3. 3 is the short leg. We have the hypotenuse, y, and that's all we know. On the median triangle, we know the long leg is 6. Oh, that's a y. And we do not know the short leg, and we do not know the hypotenuse right here. So on the big one, we know the hypotenuse is 9, because it's across from the 90. We do not know the median, but we do know the short leg is y. Alright. So we're going to cross off the median triangle. I only know one length. That's not going to do me any good. You need at least 2. Well, so that leaves me with this. Notice they both have a short leg and they both have hypotenuse. Even though we have the same variable on both, I can still solve it. So I can go y over 3, the hypotenuse over the leg, equals the hypotenuse over the leg, So cross multiply, I get y squared equals 27. So square root of 27. So I can use my calculator. I go second square root of 27. 5.2 if I round to the nearest tenth. It's going to happen a lot because you're dealing for right triangles, you're going to get decimals. Alright, so then let's see our last example. So again, draw out your 3 triangles. If you do not draw out your 3 triangles, you're asking for a big headache. Alright, so we have little, middle, and large. Alright, so in the little triangle, which is this one right here, I know the hypotenuse is 27. I know the small leg is 16. And I do not know my long leg. Alright, so then on this triangle, I have this. This length right here is z minus 16, because I know z, and then I have 16. So that's right here. I have a feeling that's not going to do us any good. Okay, and that's all I know on that triangle. And then we have our bigger triangle, where we have 27 as my short, and z. Well, taking a look, I have short, hypotenuse, hypotenuse short. I can set my proportion. So I have hypotenuse over hypotenuse. And then 26 and 27 are part of the same triangle over 27. Cross multiply and get 16 z, which I'm guessing that's 249, but I am going to check. 27 squared, 729, ooh, way off. 729 divide by 16, z equals 45.6. There we go. So review, draw out your 3 triangles. I cannot emphasize that enough. If you don't do that, you're just making it way more difficult. And then just use proportions to solve. The hardest part is drawing out your 3 triangles. But the thing to remember is that on the small triangle, this is your long leg. But on this triangle, it is your short leg. Alright, and then that's your long. And that is your short. And then on the bigger triangle, the hypotenuse is your short. Alright, so if you kind of keep that straight, that does not change. You should do just fine. Remind you to do reflections, you get credit for watching this video.